Hi everyone, I'm Eesha. I'm going to be talking about baselines in the context of tally and life cycle assessment. And to start off, I just want to pose this question that we often start with in a lot of our tally and LCA related talks is how can we reduce carbon if we don't measure it? And now with a lot of new tools like EC3 and of course tally and some other tools, we're able to in the AEC community, measure the impacts of carbon. So the next question really is, well, how can we, quantify the reductions or the performance improvement when we do measure carbon? And for this, we really need some sort of baseline or a standard to measure against. So what is a baseline? A very simple definition is that a baseline is just something that allows for a direct and fair comparison of a proposed version of the building or a component of a building with a standard or formal version of itself. And it's very important that when we have a baseline and a proposed version, the two serve the same purpose, like they have the same level of detail, same function, as well as same functional unit. So what this means from a building perspective is that the two buildings should have the same square footage, the same energy performance, same program and occupancy, and basically all parameters other than the one we're measuring should be held constant. And a very simple example of this is say for insulation types, if we're looking at a roofing assembly or a wall assembly and we want to compare two different insulation types in that assembly, we want to make sure that when we swap those out, the functional unit, which is the thermal performance of that insulation, is maintained, which in this case means that we want to have the same U value or R value. And if we're swapping from, say, XPS to EPS insulation, then the thickness of that insulation will probably change. And if this affects any other aspect of the assembly itself, suppose the adhesive type changes because you're changing the insulation type, then that should be reflected in that comparison as well. And the next question then really is, well, do these baselines in the context of life cycle assessment or embodied carbon have to be at the full building scale? And the answer is that they do not. We can try to improve performance at a component scale, just looking at different materials. We can improve performance at an assembly or a design option scale, and then also at the full building scale, of course. And we can really try to do this through every phase of design. And this doesn't mean that we need to have a fully fleshed out Revit model or even a fully fleshed out design at every stage, because it's really almost impossible to say that we establish a baseline at the beginning of design and then we iterate through that baseline throughout design, trying to improve its performance. And then in the end, we have this proposed version that we compare back to this, because at the beginning, we definitely don't have a Revit model to begin with. We don't know what the design is going to look like. It's going to evolve throughout the different phases. And we also the model resolution is also bound to change throughout the different phases. So in this case, how can we at every phase perform iterations, but also hold different resolutions of baselines through these phases? And here I'm showing just a typical tally workflow or LCA workflow, an iterative workflow where during SDs, when we start, we want to just get a general sense of what the contributions of different building components are, just a very high level view, so we know where to focus our efforts and reductions on. And then we can start to really ask some general questions at this point, because we probably don't have, the design is not developed enough for us to be able to ask very specific questions, but we can start tackling some of the more high level general questions like, structural type, which of course is determined at like a pretty early stage, and it can have huge impacts on the impacts coming from the building. And then we can also start to challenge some of the standards or the typical wall assemblies or partitions that we use in our projects. So this is something we can do during SD, even when we don't have a fully fleshed out design or model. And then during design, once it's developed a little bit, we can start to ask for targeted questions like about the material of the facade or the roofing material that we want to use. And we can iterate through a lot of different options and try to improve that compared to like a baseline. And then during CDs, we can continue to iterate, of course. And then at the end, once we have looked at all these different design options and we've decided to implement a few of those decisions, we can really like make that one like final baseline versus proposed model that we can also use for LEED or other benchmarking standards. And yeah, so let's get right into it and look at a couple of examples. So here, this example that I'm showing is from an engineering building project that we were working on. And during this project, this was pretty early on during SDs, where we really wanted to try to understand what the impacts of using a steel structure instead of a concrete structure would be. And of course, at this point, we don't have like a fully fleshed out Revit model at all. We don't have a structural model to begin with. But what we did is we worked with our structural engineer to model just one structural bay, one for the steel option and then one for the concrete option in Revit. And then using Tally, we were able to get like an approximation of what the differences in the two impacts are, for these two different materials. And of course, there was a little bit of hacking in Tally, like using the accessory materials features and then also just pulling everything into Excel and scaling that up to building scale to get just an approximation of what the differences between these two options would be. And in this case, the steel structure was performing better, but of course, this is not to say that steel is always going to perform better than concrete. It was just that in this specific case, given the criteria that we had, we were able to afford some light weighting of the steel structure in the upper two floors. And then we were also able to further optimize the performance of that steel structure using substitute cementitious materials, which helped bring down the impacts by a significant amount. And that's why it like ended up performing better in this case. And then another example I wanted to walk through is this facade materials example. So for this other project, we just wanted to understand that for the exterior finish of the facade, what are like the different materials we can use and how the impacts of a concrete finished facade versus a brick finished facade, how they stack up. And in this case, also, we use just a small section of the facade modeled in Revit and then applied these two materials to that using Tally. And we were able to get the differences in impacts for that small unit and then scale that up to the entire building scale. And we found that the brick is performing better in this case. But for questions like these, where the comparison is really just swapping materials and you don't have to like, it doesn't require a lot of like additional modeling in Revit. You could also just do this at the full building scale by creating a splinter model and then just looking at the impacts in the context of how they compare to other impacts from other materials. And so yeah, the next example that I wanted to talk about is these sort of like project agnostic design questions. And what I mean by that is questions that are not very specific to a project, but more so they apply to several, if not all, projects. So at KT, we have a lot of like very standard interior partitions assemblies that we end up using on a lot of our different projects. And we wanted to undertake this study where we just like, try to optimize the performance of these assemblies, because these are things that are used on almost every project. So it's really beneficial if we can even increase the performance by a little bit. It would like, just scale up if we apply it to a lot of different projects. So here we're looking at wood stud walls. And what we did is we held the fire rating and the STC rating as like the performative criteria defining the functional unit for these walls. And we just pulled out some examples of walls that we had been using in our projects. And one is this like just like a gypsum wall with wood like staggered 16 inches on center. And then the other was this gypsum plus resilient channel assembly. And both of these have different functional units. And what we wanted to do is just see what other alternatives we have to these assemblies where we can improve the performance from a carbon perspective while also maintaining the same function. And we looked through like the USG catalogs, and then we found these like other alternatives, both of which just switch out one layer of gypsum for a layer of plywood, and we can like get a slightly lower global warming potential number. And this study was done for a small section of the wall. So once you like actually apply this to like a full building scale, the reductions can be pretty significant. And the good thing about these studies is that they're pretty simple to do. Like you can just model a small section in Revit and then apply these different layers in Tally, and you just have those results. So you can do these pretty quickly and effectively and do them for different types of assemblies as well. As like this is showing wood stud walls, but we could do the same for metal stud walls or roofing assemblies or facade assemblies, anything. And once we have this, we could start to build like a repository of these comparisons that we can just apply to a project whenever the project reaches a phase where they're considering different options for these partitions. And then once we've iterated through a lot of different options and completed or are completing the design process, we move to this phase where we're trying to build like a lead benchmark, lead baseline model versus a proposed model. And here what I'm showing is straight out of one of our lead submissions, where we wanted to show the reductions compared to a baseline model. And through each phase of design, we asked a lot of different questions and iterated through a lot of different options. And then at the end, we chose to implement these like 5 big changes that helped us achieve these reductions. One of them was, of course, substitute cementitious materials. So for all our different carbon mixes, concrete mixes, we increase the SCM percentage in all of them. And then we also looked at different roofing membrane materials and then different insulation materials and facade materials. And implementing all of those decisions helped us achieve these reductions. And what this means for like in terms of modeling in Tally is that, as I mentioned earlier, it's like almost impossible to have like a baseline model that's established right at the beginning, and then you have a proposed design that you work towards throughout the design process. But it's really helpful to do these like smaller scale studies throughout and hold these like dynamic baselines throughout the design process. And then at the end, when we're trying to implement these into one model to see what the combined impacts are, we can just work backwards through all these iterative decisions and create a splinter model in Revit and apply these changes to that model. That's probably the easiest and quickest way to do it. And in some cases, of course, the changes are more complicated than just swapping out materials. In that case, we might have to do a little bit of additional modeling in Revit, but some of Tally's features like the dummy materials feature and the accessory materials feature come pretty handy, where you're able to ignore a certain Revit family or a certain material that's not relevant to the baseline model, but it's relevant to the proposed. And then using the accessory materials feature, you're able to approximate the quantity of a material in your model without actually creating like a 3D representation of it in Revit. So those two features are pretty helpful when it comes to like creating this baseline model at the end of design. And just to give a sense of like the iterative decisions and questions that I have been talking about throughout the presentation, I just put in an example of some of the questions that we asked for the same project. And it could be a range from like full building LCA questions to very specific micro scale materials questions about the envelope, and then also structural questions. And that's why like just keeping track of these iterative decisions is very helpful in when we're trying to work backwards to create that baseline model. And at the end, I just wanted to take a couple of minutes to talk about the differences between a baseline and a benchmark, and which is more, which one is more relevant in which scenario. So a baseline model is just something that allows for a direct apples to apples comparison of the building's performance with like a formal or more standardized version of itself, like a typical version or the path not taken. And benchmarks, on the other hand, come usually from like a large data set of similar buildings that could be like similar in size, so same location, similar program or construction type. And we use these to get a sense of what range the impacts of our building should fall within. So to get a sense of like what the starting point should be when we don't have like any idea about what the design is eventually going to look like. And at KT, in like an effort to get a sense of how our buildings perform next to each other, and also to build up like some internal knowledge and like a customized database for all our buildings, we have this like web-based dashboard. We call it the 2030 dashboard, where we're able to view the energy and carbon performance of all of our buildings together. And the goal with this dashboard really is that as it keeps becoming bigger and we're able to, as it keeps becoming bigger, we want to be able to filter based on the location, the type of the project, the program, etc. So we can get a sense of what a typical KT building looks like what the starting point is. And this will help us like achieve, like set more realistic targets and goals. And then again, of course, as the design process starts, we continue to iterate and use those dynamic baselines to measure performance so we can do better. Yeah, that's all I have for now.
Why don't we take one question live right now? One of the questions, and this is from, I think, Alex, is how do you or could you document geometric improvements? I mean, certainly like one concrete versus another, one steel versus another seems like, okay, you can take credit for that, but how could you take into consideration geometric? I mean, if know, is that something that has come across your desk?
Is by geometric, is that referring to just like reducing the quantity of materials or
Yeah,
just changing like the structure itself?
yeah. Like let's say you reduce the floor to floor height, so it reduces the quantity of envelope and the quantity of structure, for example, or
Uh-huh.
you use the window to wall ratio. Obviously, you can do that. Is there precedent or rules for that you can think of for doing that?
I think, yeah, I think that's definitely something that's like a very tangible way to reduce impacts. And I'm actually not sure if according to the LEED definition of a baseline, if that qualifies. But I think in terms of just reducing impacts, that's probably one of the first things we should be doing is trying to optimize the space itself. And like, you know, how they always say that the lowest amount of carbon that a building has is like the building that's not being built. So I think from that perspective, it's definitely something, it's probably like the first step that we should be taking. And it's definitely a valid and tangible way to reduce impacts, but I'm not 100% certain if from a LEED perspective or like a benchmarking
I can
perspective of.
speak a little bit to that, Eesha, since
Mhm,
we worked with them to put together the lead guide on this particular topic. From their perspective, it's fine that it doesn't necessarily be exactly equivalent, but it does have to have the same function, gross
mhm,
floor area, orientation, and approximate operational energy. So that's their requirements from the perspective of LEED. So absolutely within the context of that, there's great room for manipulation of the envelope, exterior geometry, floor to floor, things like that, for sure. But it does have to have the same floor area, orientation, and function.